Hey everyone, so I felt like the previous lecture was kind of incomplete, so I wanted to show this in a code so it makes more sense. So yeah, like I gave you the formal declaration and formal definition of how it works, but let's take a look at how they actually look like in an actual code. So first we are going to take a look at the durations, okay? So we already talked about the durations, and now we are going to see them in actual action. Like when does the duration matter? For example, we have this as a block scope, auto duration, right? So this X stops existing whenever it goes outside, and it is being initialized every time this function, my function, is called, okay? So let's try to run this code, okay? I'm going to use simple, compilation because I know what is going to happen or not. So yeah, just deal with it. So yeah, we see that there are no errors, right, in this code. And if we run it, we see that it works just fine. Like inside here, okay, let's comment this out for now. Compile it again, run it, and we see that this part is being printed. So this X exists here, but if we try to change that X over here, what is going to happen? We get an error. It says that the X doesn't exist or it is undeclared. That's because the X only exists within that specific block, okay? And that's why it cannot be accessed from here, and that's why it's an error. Now let's take a look at another block space. Auto duration. So this one actually has auto duration, this I, okay? So it is considered inside that loop. So if we try to access this I from here, let's see what happens. It gives us an error. It says that I doesn't exist because yeah, this happened because like I exists within this block only. Okay, so right after this block ends, it stops existing, and that's why this line won't work. In a similar fashion, this Y won't work either. Let's try it just to make sure. Okay, so it says that the Y is also undeclared, and that's why it's not working. And from this, you have better idea of how auto duration works. Whenever it goes outside a block, it stops existing. After that, even if you try to access it, it will not work. Now let's take a look at the static declaration duration. So if you put static inside a function, this is pretty interesting. Maybe it's not something you have seen before, or maybe you already did, but let's see how it works. So this code is kind of interesting because we are using a static inside the variable, and normally how it works, it will always start from 0, right? But because of this static, it is going to be declared only once, and later on it is going to actually hold the value. So if we try to run this specific function, let's see what happens. So gcc static, and we see that there are no errors, right? If we try to print it, we see that it is printing 0, 1, and 2. Even though we declared it as 0, because we are incrementing over here 1 by 1, so each time this function is called, it is actually incrementing its value. So this is going to be called only once, this line, and from next time, it is going to have the previous value of it. Okay, so in this time, when we are calling it, it is getting the value of 0. This time, because of the previous call and this x++, it is turning into 1. And that's why this line is actually printing 1. And if we run it again, we see that it is printing 2. So that's how static duration works. Even though the function returned the call, it still is holding on to the value. So this is very important, and sometimes you might need to use it, but like if you can avoid it, definitely avoid it, because it kind of doesn't work the way you intend it to work at times. Like it will always work how it is programmed, Okay, but maybe you thought of it as something else. Maybe at one point you'll be like, okay, this X should start from 0 every time. In that case, make sure that you know whether you should be using static or not. Okay, the static is there to make things easier for you, but do not get confused about how it is actually used. So I think this made more sense to you. So let's take a look at the scopes now. Okay, so the first scope we are going to take a look at is the global one. So over here, outside of everything else, I am declaring this X. So this one is actually a global scope. And if I try to run this code, it's going to print at first 0 because the value is 0. Then we are putting the value of 10 over here. So now it's going to print X as 10. And then we are calling this function, right? In this function, we can also access this specific X. Okay, so within this file, this X can be accessed by everyone. Okay, literally everyone can access this specific X. And if we go inside this function and we try to print it, it will actually print 10 because we set the value 10 over here. Then it will set the value to 20. And over here, it will actually print 20. So let's see if I'm right or wrong. GCC global, and let's try running it. As you can see, at first it printed 0 as intended, then it printed 10, then 10, then 20. So whatever I explained to you, I guess I wasn't completely wrong. This is how it actually happened. So this is how global variable works. Like global variable can change by every single function that is inside that file. So you should exercise caution whenever you're using global variable because they are very, very vulnerable. Anyone can change it and it can create weird output if you do not know when it is being changed. Okay, so that's it for the global scope. Let's take a look at the file scope. Okay, so we have said that yeah, we have said that for file scope, how it works is if we put static, it only belongs to that specific file, right? And if we don't put static before it, it can be accessed by a different file. So let's take a look at this declaration. We are calling my function. Let's try calling the other my function too as well, but it is a static, right? Let's see what happens. So it gave us an error saying that implicit declaration, and then it said that my function cannot be found. Even though it actually managed to find my function, it didn't manage to find my function too. Okay, but if we comment it out, it didn't give us any sort of error. It just gave us a warning, and that warning is happening because I didn't include the user defined what is it being called? Yeah, I didn't declare this one, and that's why it's saying. So if I declare it real quick, that warning goes away. So from this, you can see that because it had static over here, that's why it couldn't be found. But we are calling this function from this one, right? And it can still find it because it has a file scope, and that's how file scope actually works. And global variable works, but let's see if we can actually access this global variable from here. Let's try printing X. Let's see what happens. It said that X is undeclared because X is having a global scope, but it is within a file. If you want it to be accessed by here as well, you have to put it over here in the header file. And you also have to make sure that it is not being declared twice and all of those. So yeah, that's why you shouldn't be using global variables, but like it is okay to use like file like global function or global type and all of those. I'm not going to explain the structure yet. I'm going to explain it in the lecture where we're going to cover structure. But for now, I hope this part made sense to you. Give it a try by yourself. This code is also in the GitHub, and so that you have better understanding of it. And last but not the least, the linkage. Okay. So we have two files over here. Let's take a look. So how linkage work is, well, I just want to explain the extern one because you should be familiar with the rest of the stuff by now because of the duration and scope. So how extern works is, over here, I'm telling the compiler that this X actually exists somewhere else. And that X is actually over here in this like linkage 2. And thanks to that, let's try running it and see what happens. And it compiled, it didn't give us any error. And when I try to run it, it actually prints 10. So by telling the compiler that this variable exists somewhere else, it is managing to find this one. But if I didn't put this, let's see what happens. It is printing 0. So because in previous lectures, I kind of explained that Linux does an optimization, in which case every variable is actually initialized by 0, but you shouldn't depend on it. Most of the time, it is actually initialized with garbage value. So technically, it should be printing garbage right now, but because we are running this in Linux, it is printing 0, and that's why it's happening. So yeah, I wanted to show you these examples to make better sense of the whole, like the duration, linkage, scope. If you still have any confusion about it, just let me know, okay? And I'll see you in the next video.